CIT 1121, Module 8.2, IPv4 packet. We're taking a look at the IPv4 packet. Specifically, we're going to look at all the fields inside of the packet header. Now, as we've moved on in class and we've done some drawings before, whenever I talk about the packet header, I talk about the source IP address and the destination IP address. And those are the only two things that I ever talk about, but there are a whole bunch of other fields that are also inside of the packet header. And that didn't come out very good. Let's try something different here. See if this, hey, that doesn't look so bad. So if we look at our PDU as it is normally formatted, let's see if we can do some better drawing here. And we can draw our 4 parts here. We've got a frame header. And that's pretty cool. And then we have a packet header. And that's pretty cool. And the next addressable component is called the segment header. And of course, this is going out this way. And the last part is the data section that we want to deliver to the other device. There may be a little CRC at the end. Cyclical redundancy check, we talked about those in the past as well. So the frame header contains MAC addresses mainly. MAC addresses are read by switching devices. So a switch is going to read what's inside the frame header and make a forwarding decision based on that. Packet headers mainly have values known as IP addresses or a global address. So an IP address, those are read, well, they're read by the destination device, and they're also read mainly by routers. And routers make forwarding decisions based on the information inside of the packet header for the IP addressing information. Specifically, we're going to make our forwarding decisions based on the source and destination, mainly the destination. The source is merely there so that we can get a return trip and have a contact communication. Inside of the segment header, which we're not going to talk about today, but we are going to talk about pretty soon, we have what are called port values. And port values just identify what services on the receiving machine would be using that. So that would really be the end host would be the device that would be looking at port values, so source and destination ports. Also, if we wanted to put another thing in there, we could say firewalls are big on reading ports. And those are the 3 addressable headers that we need to be aware of, not only in this class, but if we're going to be networking professionals, these are the things that we're going to be looking at specifically and finding if there's errors or issues or problems. So we need to be really adept at looking at the fields inside of these headers. In the last couple of chapters, we went through, or modules, we went through the frame header, and we talked a lot about Ethernet 2 and how inside the frame header there's a source and destination MAC and a type field. And the type field doesn't do anything but identify what version of IP or what we're using inside of the packet header specification. So that's that's where that's at. So let's take a look at the fields that are inside of an IPv4 header, and let's talk about what each one of these fields are, okay? And then we'll go back and we'll take a quick look at what one of these looks like in a capture from Wireshark. So I've got a Wireshark capture that we'll look at, and we can look at what this looks like. We were actually, hey, people are sending this data, and you can decode it. It's essentially decoding. So that's pretty cool. Here are the fields inside of the IPv4 packet header. There is a version field. The version field will always be listed as version 4 for this particular, for IPv4, because it's IP version 4. Pretty straightforward. The next field that we're going to talk about is something called differentiated services. Sometimes you'll hear this called a DSCP values. These are set for QoS. QoS stands for quality of service. And what it means is we can build a pecking order or a hierarchy of data based on checking off these fields. And we can make some traffic more attuned to getting to a destination faster than others. So that's the idea behind the DSCP values, diffserv, QoS, TOS type of service. We can use this to expedite traffic based on the type of traffic it is, and we can identify it here. It's not used a whole lot, but it could be done. The next thing is the header checksum. The header checksum is just going to give us a total on how much data that we have in the packet header for IPv4. One of the differences between IPv4 packet headers and IPv6 packet headers is IPv4 packet headers are of a variable length, And IPv6 packet headers are of a fixed length, so we need a checksum in IPv4 to make sure we have the whole thing, because it could be more or less than 20 bytes, but it's usually around 20 bytes. So just keep that in mind. The next field that we want to talk about is something called time to live, and it has nothing to do with time, and it has nothing to do with life. What it has to do with is how many routers can we cross before we blow ourselves up, right? So I think we've all gone on trips to destinations and didn't have Google Maps or whatever, and we're like, oh my gosh, I can't believe how long it's taking. I've gone the wrong way so many times. Well, it's possible in networking, too, to get caught in what's called a layer 3 loop, which means that the instructions that you're getting from specific routers will actually send you in a circular path instead of getting you to the actual destination. And circular path in networking is bad. The traffic doesn't get to where it needs to go. But if we get too much traffic in a circular path, it gets even worse, because that'll be taking up the space for legitimate traffic that can get routed correctly. So there has to be a mechanism to take the circulated traffic off of the system. That's where time to live comes in. It'll usually be a value like 64 or 128 or 32. It'll be a number, and this is essentially the number of routers that you can cross before the traffic cannot be forwarded anymore. The traffic just gets to a point where it's like, you know what, we're not finding our way to where we're supposed to go. Let's just give up. So when the traffic is first sent from the source to its original router, it'll go from 64 down to 63. It'll cross that router, it'll go down to 62, so on and so forth. If it gets down to 0, it stops getting forwarded. That's all that is. That's time to live. It has nothing to do with time or living. Great. Protocol. We are going to start learning about the segment header, and the segment header has two major protocols. One is TCP, and the other is UDP. And we're going to want to identify to our receiving device which one of those it's going to be. It could be something else, but it generally be one of these two. The protocol field just identifies this is TCP or UDP or ICMP. Well, we'll get into those later. And that's all that protocol does. It's just it should be called next header, and strangely enough, in IPv6 it is called next header, which is a pretty good name for it. And then the last two things are a 32-bit address value for the source IP address, the device that created the information, and the destination whom is supposed to process this information, and that would be under the destination IP address. So we'll work with these to a very in-depth level in future slides, but for now, just know that these are the fields that are available. Now, I'm also going to go, I used a product called Wireshark, and I don't think we've really talked about it very much in class, but if we take a quick look here, what I've done is I just captured a packet, I captured a stream of packets, but this is one that I want to look at. Maybe I can make this zoom in just a little bit bigger. There, it's a little bit bigger. And you can see that this packet that I've captured, it shows me each one of the headers here that I can break out. So this is actually, where it says Ethernet 2 here, this is my frame header. Check this out. I open it up, and look at this. I got the destination MAC address. I got the source MAC address. I got the type field that says, hey, by the way, the next header that's coming in is IPv4. Great. Cool. I'm going to close that, and let's look at IPv4 headers. So let's look at this. Well, this is going to look really, really similar to what we just went through. My very first item that I see in here is the version value. Then I get a length value plus a total length, which is that checksum. I have my DSCP values, my differentiated services fields. I have an identification field. I don't know how that didn't make the slide, but there's a whole bunch of stuff that in case you fragment your traffic, I forgot that should have been in there. That's okay. We can talk about it. Here's the deal. Identification, flags, and fragment offset all have to do with fragmenting IPv4 traffic. So let's suppose that you create a PDU, and that PDU is 3,000 bytes for whatever reason. You send it on its way to its destination. Well, it gets to a path, and the maximum transmission unit for that path is only 1,000 bytes. So now what are you going to do? What you're going to have to do is you're going to have to take your 3,000 bytes, break it up into 3 pieces, and send it on its way. Now, when you break it up into those 3 pieces, you have to have a method to say, hey, if we're going to break this one up into 3 pieces, the next one that's coming in 3,000, we're going to break that one up as well. So we need to be able to differentiate this one from the next one, and that's where the identification field comes in. Then with our fragment offset and our flag values, we can tell it, well, one of the things we can tell is not to fragment it at all, just blow it up and stop forwarding it. But let's say we don't check that off. What we can do is we can identify the first, second, and third pieces, so when they arrive at the destination, we can put it back together in the same order. So fragmentation, keep that in mind. Don't know how that didn't make the Cisco slide, but who cares? Next field is time to live. And time to live on this one is just 1, so 1 more hop. Protocol, UDP, so TCP or UDP protocols is what we're going to look at. And right down below that, we have our source and destination IP addresses. And those are the fields of our IPv4 header. So hopefully that was informative, and we'll do some labs on these coming up.